Woo! So basically, long story short, the way this is gonna work, we went in and the other day we created a bunch of archetype presets for the different types of galaxies. We have E0, E3, E5, E7, S0, SA, SB, SC, SBA, SBB, SBC, and irregular here. So these are codes that correspond with um, a galaxy classification chart that I pulled up. And then we created a probability table based on an estimated probability of those galaxies to spawn. And then we started just returning an archetype. So that's good, but it's not enough. What we actually need are randomization bounds for each of these to generate different galaxies of each type, but within the like a bounds. Um, so I actually really like the way that so instead of creating like a second struct to manage the randomization bounds, I just created two copies of a min and max struct for each of these, and that means that we can then configure these individually for each type and use them for like our randomization bounds. And there's galaxy weights here. And that configuration is going to take place in our Galaxy Param factory constructor. So, for example, here is our construction of the E0 archetype, which is like a spherical cluster. Um, and then what I'm working on now is our randomization bounds for each archetype. So you can see here I have um, a series of parameters that correspond to E0. And what we do is we configure the archetype, and then we set our min and max to our archetype to start so that anything we do not set will just inherit from what our archetype was. And you can see here I've already randomized some of it, like Bulge Axis Scale has a min and max. Bulge Acceptance Exponent has a min and max. Bulge num points has a min and max. Background num points has a min and max. But what we actually need to do, we want to give it the ability to have some like very lightly populated clusters generated for this. So what we need to do basically is go through every one of these archetypes that we've got. I think there's 11. And we need to come up with randomization bounds for anything that would apply to that archetype, and then we need to test them. So that's a lot of work, but it's not like complicated logical work. It's just the fun part, which is like changing numbers around and seeing the result. So there's a couple things we're going to have to do. So for one, we're looking at E0, which is our zero index, and we have this select galaxy index here. So we need to go here. And we need to make it so that what what okay, whatever, we'll find it here. We need to make it so that okay, I'll show the code for how this works too. So we basically have a select galaxy type index and then a switch. So we select the galaxy type index and they correspond to this comment here. So 0, 1, 2, 3, 4, blah, blah, blah. And this function is what's doing our like probabilistic determination of what type of galaxy we'll generate. And then we come down into the switch statement, and for each case, so 0, 1, 2, etc., that corresponds with the type, we call this bounded randomized params E0 min, E0 max, E3 min, E3 max, E5 min, E5 max, E7 min, E7 max, etc., for every one of our galaxy type. So that means that when this function is done executing, we're going to have a list of params that were randomized between these two as being between the values defined in these two structs. And we're using the structs that correspond to the galaxy type we want to generate. Finally, here is our bounded randomized params, which hits every single param in our thing. We have some that we have to come up with that have to do with the volume texture that I haven't done yet, but almost everything has already got a randomization call in here. And if you were to provide the same struct like we are right now for most of these, you would just get the archetype back. But if we randomize the archetype min and max, we would get values that range in those bounded ranges. So that covers how we're going to be randomizing these. So basically all of that is done, and the only thing we have left is over here in the constructor. We need to actually define our randomization bounds for each type, and this is going to be a huge constructor. It's like, but it's there's no logic. It's literally just it's like imagine setting up like a material parameters collection, except for our thing. Like we're just changing all the params that affect the generation within some acceptable randomization ranges. So what we need to do today is basically for each type, we need to go through here and randomize everything and test it and look at a few different copies of the galaxy that's being generated from it and make sure that it makes sense. And the way we can do that is since we're looking at E0 right now, we need to randomize this one. We can kind of randomize them around a default the range of the default value that's already set on it, and we can force it into returning a specific index that we want to test in our simulation. So right here, for example, I could just return 0. Manual to do. So we don't forget, we'll say remove manual return after bounds testing is done. And once we finish this, we're going to do a similar generator for the universe, but I think that that one is going to be a little bit simpler because Galaxy has a way more complex or recognizably complex structure than a universe, and the universe is something that we could probably fudge a little bit easier. But anyway, we're going to return 0 for now so that everything we get should be a type 0 cluster. We're going to come over here to the header, and we're going to start randomizing values. So basically what we want to pull up is... so we're not touching arm or disk for this. We have their points set to 0. We will touch bulge, potentially cluster. Yeah, potentially cluster and background points, along with the rest of these parameters here. So we've done bulge acceptance exponent, bulge axis scale, bulge base density is set to 3 here. So we could set like a min density equals 2, max density equals 4 type situation. Bulge depth bias is currently set to a 0.2 here. So let's do like a 0.1 and like a 0.4. Bulge num points. I'm just looking at the background base density. We can try like a 5 and a 25. And then bulge depth bias. Background depth bias. Did we set that up here? Do a background depth bias of like a 0.6. Or let's do like 0.7 to 1.3. Background height ratio. We'll just say that background starts to be a 1 for this. So we don't actually need this one. Do I want to change my background stars to also operate off of a... axis scale. I might. I might. I guess we can always do that later, especially if we're just going to set these to ones. Bulge radius scale. Okay, I remember this one. It's set at a 0.3, so we could do like a 0.2 to a 0.4, maybe. And then bulge ratio, let's do a 0.8 to like a 1.2. Bulge truncation scale. Um, let's see what that's set to by default. Set to 1 by default. So let's try like a 0.8, maybe like a 0.7, 1.3. We also want to randomize our base settings, so like galaxy ratio E0 dot E0 min and max. And yeah, this part's going to take a while because it's just a lot of busy work, but this is kind of the fun part too. Maybe something like this. Okay, so that covers two pieces. And then we also wanted to do this clustering stuff. Um, so let's take a look at our, first of all, cluster num points. This should be easy. We'll do a minimum of 0 and a maximum of, let's say, 100,000. And a minimum of, like, 20. Maximum of, let's do 12 and 64. And then we need to figure out these other values by looking at our irregular generator. So we don't want to generate enough clusters for this to like dominate. Our cluster axis scale can E0 min. Our cluster axis scale here should be, for this type, derived from our bulge axis scale. Okay, that's going to be a little bit of an issue. Um, Just recycle our min and max here. This is going to be a bit of an issue, maybe. It's probably okay for this. Okay, cluster base density. Uh, like a 2 to a 4, maybe. What did we use for background? Or for bulge? 2 and 4? So we can do 2 and 4 here. That's fine. Cluster depth bias. We'll say like 0.1 to 0.3. Cluster incoherence. We need to get these values from our irregular generator values. Okay, Da, da, da. Background num points, background base density, cluster num points, cluster incoherence, cluster num clusters, and depth bias. Okay, depth bias is 0.75 right now. Oh well, we did that one. We've already done this in num clusters. We need incoherence. I think that might be it. Incoherence. So we go back up here. Cluster incoherence will say 3 to maybe like 6. And then what's my definition here? 3 and 0.7 are what we were using. So for our minimum scale, we could do like a point. Oh, this is max. Like a point 0.8 to a point 0.6. And then point 0.2 to like a point 0.4. And then cluster spread factor. What's our default here? Definition. It's 0.35 default. So at a 0.35, so we do like a 0.25 to do like a 0.25 to like a 0.45 or something like that. All right, and now so we should have this one pretty much done. Let's give it a shot. Yeah, this is the fun part for me because this is where we've built all the tools and we're just using them. So if we get this and this looks good, then we have our archetype for our E0 galaxy type, which is spherical globular. What's my error? Build errors. Man, lame. So for now, we're just gonna control KC, control KC. Okay, yeah, there we go. Basically, we just want to fudge it to always return the galaxy type that we're working on while we're doing this. And then when we're done, we'll remove this and we'll be back to selecting between all the ones that we've kind of fine-tuned. But yeah, we fine-tune each galaxy type. Right now we're doing, like, the clusters should be somewhat easy. Or the types that we're in right now should be somewhat easy. We get into the spirals, so those will be a little bit more complicated, but we can kind of lean on settings we've already done for other ones, because a lot of these settings will be similar between randomization, different types. All right. All right, we got a bug. Thought we might get some of this. This is in the renderer. I'm not convinced it's our fault. We'll try again. I mean, it's probably our fault, but I don't know that it's the fault of the changes we just made. Like, we could have some stuff in cluster that we haven't configured properly. If it happens again, it's our stuff for sure. But no, we got past it. All right, we got a random cluster here that we generated. Okay, this is an issue. There's some patterning going on. If I turn cluster off, are we still getting the patterning? So we'll turn this to 0 and reload it because I have a minor suspicion of what it might be. It could be related to the way the clusters are being generated. Um, or maybe I'm not using a seed properly somewhere. What I was thinking is that like the clusters are getting generated but not offset enough, so they just like overlap. But then that would mean they weren't getting seeded correctly either, which is, oh, you know what? I think cluster operates on its own internal seed, which is not going to be viable. It needs to, because then it's just doing the same cluster over and over. No, it's still there. So it's actually in my Hernquist or background generation. Let me check that cluster generator actually. Point cloud generator, cluster. Yeah, so stream. This would generate the same. Yeah, this would generate the same clusters. So this is a problem. So what can we do here? We can provide a seed to this. And then use that instead, and then externally where we call this. Yeah, okay, that's a good fix. It's not going to fix this, but it is going to fix something. So in my header for my generator, not my factory. Jesus. Alright, so we do this, and now we're going to have errors over here, but only in a few places probably. Um, plus. Yeah, C plus, I don't know. Generate cluster, yeah, and then we have another failure here and here. I think this is going to need an additional jitter step or something. I plus 987654. Okay. So that's the big one. There's another one here. This would be like arm index plus C. Arm index plus C plus 1, 2, 3. All right. So we need to look at the component parts of the thing that we're working on. So right now our cluster is exhibiting some signs of cohesion that we don't want to be there. Inside this function. Oh my goodness, mailman's here. Let's see. So just looking at how I did this, I need to probably introduce some jitter here, but I need to check a couple things. So we need to go to coworker. Okay. All right. Patterning. Oh, background also would have had it, I think. Oh, I changed them. Okay, cool. Um, all right, I'm pretty sure it's in this generate clusters. I need to turn off some stuff. So that's in generate data. Okay, it does this. So right now, we want to fix this generate bulge issue. So we will just comment everything else out. We need a similar distribution, but it can't be this blatant of a repeating pattern. We may have to go a level deeper in the octree. All right, this is only the cluster. Yeah, it's in this. So So this is all fine. Then we do this. Okay, yeah. Some cohesion slash patterning in one large function. Stream seeding line with F random stream. Let's see if this does it. I doubt it, but we'll see. What? How do I have a spiral? What the fuck? The fuck? I mean, that's actually kind of sick. Okay, so the fact that this has a pattern that repeats is actually not a bad thing because we could randomize this further. But this is making like it's like each individual has almost got its own orbit, which is how it really would work. So if we randomize this, um, wow, that's really interesting. Okay, so hang on. So times axis scale times stream dot fn range, and we'll do like point 8, maybe 0.9, 1.1. Or should it be like, maybe it should be like this. I don't want to overflow my bounds. All right, let's see how that looks. Add 10% jitter. Still patterning. Do I need to turn down? All right. I think we might need to turn down the depth bias. Bulge depth bias. That's cool that it's kind of operating in a spiral fashion, actually. And I think that it might be useful with jitter. We're gonna see. Okay. So we turned down the number of extra bright stars. No, hang on. Okay, there's less, but you can still see some coherence here. So then we can also increase this. Yeah, it's getting better. It's like there's still influence, but less visible patterning. All right. It's better. It's definitely better. 0. No, we don't want that. We also do like because the only thing is this is gonna affect like fall off if I do it like this, biasing towards the center. We could also do something like this is a better way to do it. Okay, so this would be a 3% of total radius jitter. And I don't think I destroyed it. I mean, I'm seeing some clustering, but I'm not seeing any kind of patterning anymore. Not like, oh, it's directly in a line. Like there's clearly spiral, but that's good because this is a galactic bulge, so like having some degree of spirality is good. Nope, there's some. Okay, jitter's not enough. Did our bill go through yet? I feel like that's better. That definitely looks better. And back over here, we can. Where is this coming from? Okay, I see, I see, I see. It's computed, so that's fine. editor. What do you mean? Link generator CPP 590. Okay. All right, there we go. Yep, that makes sense. This is a one-off or okay. No, it actually worked. It's fine. We can restart it anyway. So like this is just basically the final pass to make sure everything works the way we want it to, and also randomize our different archetypes in the process. This will probably take a few days. Let's hit it. Okay, this looks good to me. I don't see any patterning anymore. And there's like kind of a nice like spiral feel to it, even though it's not like very obviously spiral. It has like kind of spiral vibes. So I like this result. And then we need to fly between different ones. So that's like actually we should do screenshots. So let's do that. Actually, before we do that, we have to start bringing pieces back in because we disabled everything to debug that. So now it might generate data. All right, I want to see the cluster portion. Live coding succeeded. Let's go see what the cluster looks like. Not bad, actually. Not too bad, actually. Um, so for this one, I do think that it probably needs a lower amount of cluster points. So inside our factory, Cluster. Yeah, here. Let's just do a small quantity. All right. So now let's combine the two. We can actually just combine everything back in. I think it's gonna look fine now. We had some coherence in our generate bulge, but now we don't. All right, let's see. Unload it, reload it. Looks pretty good to me. All right, so that's one. Let's go see another. Okay, so what is the cause of this? I mean, it's kind of cool, but it's not desired. We're getting maybe all negative numbers in the composition. I mean, that's pretty cool. Let's see if it happens every time or not, or like very frequently. I did it here. Or composition calculation should probably be normalized. Didn't happen in this one, though. I'm not getting, like, I'm getting different vibes from each one. Yeah, they're all different. So I'm pretty happy with this so far. We have to figure this out. This is gonna have to do with the composition. What is probably going on is maybe they're going negative. Let's see where we're doing that. Um, right here, or actually right here. Let me think. Um, so this is coming from the insert data. The insert data is generated as a part of all of these. So which system do these stars belong to? Let's see. Insert data. This is fine. So what we actually want to see is everywhere we're using this. But inside galaxy. So it's got to be here or in background. So let's see. Insert data. Insert data dot data composition equals unit vector. Where was this being touched? Data. It wasn't. That's gotta be it. That's gotta be it. Although it looks like it might be in background too, but we'll find out here in a second. Yep. All right, so now they're behaving as expected. I think the clusters actually need to be toned down for this even more. Zero, 20,000. And it might actually be the case that we would be better off using our like little Gaussian generator. But either way, I think we fixed that. All right, so we look at that one. Let's go look at some others. It's definitely different. I think I also want to add a delay. Very short one, but I want to add this to be in the galaxy actor. Inside spawn, initialize before the call to initialize data. Um, I want like a 0.1 second delay right here. And I am short. Something like this. And now when I zoom past them, it shouldn't potentially cause it to chug. Because like formerly, if I zoom past like 3 or 4 galaxies, it would kick off all those parallel fours. But now we have a like grace period before it'll load it. So I want to test that as well as this randomization of the our base cluster type. So like if I increase speed here, yeah. Okay, now we're cooking. I want to do a few screenshots here and compare and contrast in GIMP. Okay, let's go see a different one. What the fuck? Get out of here. They are pretty different. Yeah, this is looking good now. Substantially different appearance. Alright, I think I'm satisfied here. This one's good. So what else did we need to do? Oh, over here. Okay. This is gonna be kind of a pain. Um, we need to attach the or randomize the material parameters. Min and max. And min would be volume. Volume. Coherent scale was the last one. Volume noise is a special case, but we can just put it here to keep the order. Right. We have one more even. Volume, ambient color. No, saturation variance was the last one. So temperature scale, temperature influence, volume warp amount. Scale. All right, and now that we've done that, we can. Okay. So now we need to randomize these. Or at least establish random bounds for what we will use to randomize these. We don't have to use this data in the same way. Um, we don't have to use this data in the same way that the material is because we control the randomization stage, right? So if we wanted these to be like Q shift amounts from a baseline or whatever, but we do have to figure out randomization bounds for the volume material. Um, we can do that in kind of a block, though, I think. Ambient color. So, like, cool shift and hot shift, like, I know, like, we could pretty much. This is a vector, right? Yeah, so for cool shift and hot shift, we could do something like. And, like, this is shifting cool, so RGB, so red would be low, green would be mid, blue would be high. This is cool shift. So we're talking about mins. This would actually be like closer to zero. And this would be probably like a 2.5 maybe. And we could put this one at like 0.5. And then this could go up to like a 3. This could go up to like a 7. And this could go to 1. And then we can just flip those numbers. 5, 2, 5, 1. One, 7.3, something like that. And then what is our density at right now? I think we need to change the density distribution as well. So I would do like, that's probably fine. We may need to come up on the background density to get like some better fog coverage. This value, yeah, we need to bring this background density up. We do like a 0.1 to like 1.5. Something like that. This would be like 0.01, 0.25, maybe. This should be like 0.52. I forget. Hang on. Hue variance scale. Those being set. Bet they're being set. U variance scale. All right, I mean, we'll just leave it for now, right? Volume noise. Okay. Um, we don't need this one here. This is randomized a different way. Volume saturation variance. 0. 0.5 maybe. Volume temperature. I spelled this wrong. God damn it. Okay. Well, for one thing, in our base params, we need to define these, and that's going to come from currently here. So we're going to take this and move that logic into. Okay, great. We don't have to set volume ambient color actually. All right, so this could just be. So temperature influence set to 32. Point 0.1 to 1.5. So like a point 0.5 would be like our average. We're just building like a basically like a prototype here, right? Volume warp amount. And I think I want to change my volume noise to just be a string path. Warp amount. We need at least like 0.02, 0.03-ish. Um, oh, this is the prototype, so like 0.05. Okay, and this, we're going to change this. Alright, so over here in Galaxy Actor, we actually have this array here. Um, okay, so I'm not setting the noise texture on it right now. So this is going to be new. We need coded trees. It'd be the same idea as this of string. How can I load a texture from path string to set here? gonna say textures in a folder. Okay, so this should be fine. Or this. I'll do this. So this is gonna be SVO slash volume textures. My volume texture would be da, 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 da. Okay, sure. So we got four. Um, so we've been using this one as our default. So VT Portland Worley balanced. I think that's how it's spelled. No, just Orley. Okay. Orly. Orley. Berlin Orly balanced. Okay, great. So we actually need all of these, but for now, I'm just setting it up like this so that we have an example. Um, what we're gonna like, we need this. And then over here in point cloud generator header for the factory. noise paths. For these, what's our next one? VT gradient L5 256. L5 256. VT gradient L5 256. Yep. VT gradient turbulence. I'm going back into here. Gradient turbulence L5 256. Okay. And the last one was VT Voronoi something. Voronoi L5 256. L5 256. Alright, there we go. And now, this becomes care array. And it gets this. Okay, and then finally, now that we have all of this, in our randomizer function, which is actually over here, don't actually need any of these lower windows right now. Let's reclaim some space. Okay. Alright, generate arms, apply twist, blah 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 blah. Volume. Noise paths. Um, 0 to 3. We can make it an F string. Yeah, that's what we'll do. Does that work? Apparently he's happy with that. Fine with that too then. Okay. And then, so that covers our randomization of that. And then finally, so now that all this is set up, galaxy generator here. Yeah, this should work. Yes. We don't need this here anymore. Unless we're using it further down. Yeah, this is gone. This volume, nice. And now you don't need this. Change the noise texture. Oops, nope. Here. Okay. Continuing down the line. Ah, sheesh. It's a ton of these. Saturation variance. Temperature influence. Scale. Density. Uh, amount or scale. There we go. Okay, so now that should come from our galaxy initialization. Yep. All right, great. And then what? That doesn't make sense. All right, so we randomize the noise paths. We do bounded randomization for everything else. We need to look at our bounded randomization function, go to definition, because this needs to randomize our volume stuff. We'll just do this. Um, F linear color, and it's gonna be stream and it's gonna be min params dot volume dot r max params. We don't need this. Okay. So that's R, G, B, end it. So we just do it like this. And for the rest of these, we can get rid of this. We can add that random selector here actually. So data this. And we can get rid of that from here. And then all we gotta do is just paste, oops, nope, like that. Paste, 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 paste. Copy, paste, 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 paste. All right, now everything is set. So now, back out to galaxy level. We verify that. Okay, so now we should be getting procedural gas. Let's see. I use all three because I don't pay for any of them and I'm just using um up to the limits. But like I don't know, like sometimes it's better, sometimes it's worse. I think it's best to diversify. You could ask the same question to all three and then pick the best answer, that kind of stuff, if it's something that's actually challenging and you get different answers. So more ideas is better. Okay, failed to load something. You want to take a look at that. I need to create that material. Alright, gas looks good. It's also random. What about over here? Different. It's different. Nice. Good. That's what we want. Cool. It's working quite nicely, actually. Quite nicely. All right, well, I'm pretty happy with that just out of the box. Very nice. Okay. Um, get rid of all of this. All these comments. All right, so we have one archetype of our 11 archetypes fully randomized. We reintroduced randomization of like our texture parameters, including the volume noise, which is really nice. So now, this stuff needs to be randomized. Um, so let's. All right, and then the cool thing is once we've got this, we can use we can use this for um, every single one of them probably. Okay. So let's do the ones we know, cause like this would be like a point oh 0.5, 0.15, warp scale, point 0.2 to like point 0.7. So we just need these two. I don't think this one even really needs to change, but let's go see what we set as our baseline. Okay, so this is at a 1, and this is at a 32. So we probably want to go between like point oh 0.01 to like 6. Let's see, let's mess with it a bit. Let's find one with a little bit more dramatic gas. All right, great. Now let's get Ray Marcher and crank up temperature scale. Oh, these are being okay. Yeah, we're decoupled now from this, so I can't fix it that way. We have to do it in here. So this is with a temperature influence of 32 and a temperature scale of 1. So what we're gonna want to do is just use those numbers, 1 and 32. 8, 60, or 8 and 48. And minimum 8.1 maximum. Try like a 10. And then we can just cruise around and see. I need to turn down the detection radius. I'm going to do that here in just a second. Alright, so there's that one. After our changes to the temperature stats. Yikes. Okay. I mean, these are looking pretty good to me. Alright, so far so good. I think our number of bright stars needs to decrease a little bit. In our randomization range, that's our depth bias. Or it actually needs to increase, but that... So far the density, or the gases looked good. Alright, cool. Pretty happy with that. So, like this, for example, this all impacts the texture. So I almost want to declare like a volume min max and then use it because otherwise I'm gonna have to declare these for every single one of these. But if I did like this, then I can just use these two and do it once. So what we basically do is come down here. Oops. Oops. Damn it. can move this up to the very top because this is independent of our galaxy generation itself. So for even our archetypes, we configure these, and then inside our implementation of this, and then the individual generators can just focus on the density of the components they're generating instead of like the volumetric material settings. We just always pull from our volume min and max for this last little block. And now we don't have to repeat that configuration for every, like, we don't have to repeat this for every single randomization bounds, like archetype randomization bounds. Because, like, if you look at this, this is already a lot for one, and this isn't our most complicated one, but this is what it looks like when we're done. So we've got an archetype here. It's randomization bounds. I want to figure out how to make this collapsible. Um, how can I mark sections as... you could do it with common. Okay, that's what I was looking for. Visual Studio section. section C plus plus. Okay. Okay. Sick. Um. Okay. Yeah. This is great. Okay. I definitely want these in line. Sick. Okay. This is great. So we can go ahead and like break out our stuff into regions here because like this is just a big wall of text. It's hard to kind of cope with. Uh, Pragma region E3 archetype. Think we can actually um we can just go ahead and define all the regions that we're going to have to build out, and then when it comes time to work under them, it'll be a little bit easier. Okay. And then when these are done, we'll tab them over. Although we can go ahead and tab all the end regions over first. It's like a lot of busy work, kind of, but will help us in the long run because we have to do a bunch of these. Jinx, hey buddy, you complaining about the world? Okay, and then we need one more. Grab this, paste it, bounce, tab, control C. Add a bounds region for each of these. SBC. Tab. We're just putting in the stuff that we don't want to have to retype over and over. Alright, and now we go back down the page, putting all the end regions in place, and then the only ones that are out of place should be the ones that need our attention. And we go back up the list one more time, fixing those and tabbing them into place and collapsing the segments as we are done. A lot of times when I'm coding something that's like big like this, I'll do stuff like this where I intentionally format it in a shape and then do like passes over it, and then I don't have to actually like look at it. I'm just looking at the shape. So now, like, as I go back up the page, right, I know that everyone that is not tabbed needs attention. So SBB, now that one is correct. So we can get rid of this. We add a space between each one, and then like this one, SBB, and then we know that one's good, so we put it back into place. Added, and like things that I know I'm going to repeat, I will a lot of times do like before each archetype there's going to be a space. So we're just going to go ahead and do that so we don't have to keep doing it each time. Okay, there we go. Alright, and now we just have to make our way back up the page, and everything else should be formatted. So this is SBA. Tab, SBA, tab, downsize, SC, SC, downsize, region, SB, SB. Downsize, downsize. SA. SA. Tab, tab. S0. S0. E7. E7. Again. Downsize, downsize, downsize. E5. E3. 3. Alright, now we have everything broken up. I love it. That's great. And E0 is the one that we just finished. So, like, here's our archetype. Here's our bounds. So basically the next thing we want to do. Ah, shit. We have to fix all of these. So it's reasonably likely that we can duplicate our randomization bounds that we built for our first cluster type for basically all the cluster types, but just with some slight modifications. Like basically it comes down to the shape of their randomization area. Okay. Clip that out. There we go. All right. Um, so now we're all set up to start randomizing other types. So right now we're only returning our E0. Let's go ahead and start returning our E3 and set up bounds randomization for that. So what we're going to want to do is come over here to our implementation of this, change this to 1. Come back over here. Okay, here's our archetype. This is going to be similar because it's just a slightly more oblong version of this. However, we do have the unfortunate task of having to replace the letters in every single one of these, but we can do that. Numlock off, insert. Three, 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 three. Oops. All right. And then what we're going to do for this one is we will um, turn insert off, add one of these. There it is. Okay, so it's this. We'll say our minimum for this type would be like a 4, 5. And our maximum for this type would be like a 7. I think that's it. That's all we have to change. E5 will be a little bit more complicated because we're adding in the disk, but not too bad. Basically, every time we add in a component that we're using, like we're not using disk in either of these. Okay, let's take a look at our E3 types. Just like a little squished version of the other one. Seems fine. I love it. Okay, great. So yeah, that's why it's kind of nice. Like once we get one of them, it gets a lot easier to do the other ones. So, so E5 would have similar stats here, but but it will have additional randomizations. But the first thing we got to do is go into insert mode again and do. Oh no, 5 is one of the keys that sometimes doesn't work on my keyboard. This is going to take a lot longer. Tool deficiency. So if you've ever seen me typing and it's like, it seems like it's weird or I'm making weird typos, it's not me. My keyboard is fucked up and some of the keys don't always press. So like one press, nope, 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 one press. Okay, it worked. Press, it worked the first time. Press, it worked the first time. Press, it didn't work. Press, it didn't work. It didn't work. It didn't work. It worked. And that actually is really fucking annoying, but it's a laptop. and I don't know what to do about it, unfortunately. So, like, the other one was easy, but this one was a pain because the keyboard doesn't work half the time. Okay, so Bulljax's scale, I think, stays the same, but we have an added disc here. Um, E5 min max dot dot disk one, two, three, four. One, two, three, four. Delete is another one that fails, but backspace doesn't. Alright, disk base density. Base depth bias. Depth bias. Height ratio. Height ratio. Num points. Num points. Okay, that's all we got for disk. Okay, if our archetype is up here, we have 50,000 disk points. So, like, do like 25,000 to 100,000. Base density. Depth bias. 0.8. 1.2. Height ratio. What's our height ratio here? 0.3. So do like a 0.15 to 0.3. Or like 0.4 even. This is 10,000. Man to do a hundo. Okay. Alright, now we have E5 configured. So we can get rid of the ones that we've already done for now. And we're on E5. We need to test E5. Um, so to test E5, we need to return a different number. Okay, great. All right. So this should be an E5 now. Yeah, so now it has that disk, I think. It did successfully compile, right? Yeah. Yeah. Okay, let's just go to a couple other ones. Okay. I think it's working. Yeah, right. Pretty happy with that. Alright, so now we're back over here. It's nice that like it gets easier. So E5 will be similar to E7. I don't think 7 causes issues on my... Well, nope, it does. Seven. Primary difference between 7 and 5 is the number of points in the disk and the disk height. So Bulljack's scale comes down again. 6, 3, 5. Disk num points goes up. $75 to let's say 125. Disk height ratio comes way down. 1 and 2, maybe like 2.5, because um, we do have one that will be thinner than this with more points in this, so we should probably keep it. And we could probably drop disk points a bit and background points a bit. Okay, cool. Oh shit. This is E7, huh? Okay, we're gonna have to hang on. Change this. Yep, looks good. All right, these are looking pretty good, so let's go to the last type we've got in the non-spiral or irregular types. So that's going to be 4 here, and we gotta go back over here. This is our S0. It's going to, again, be similar parameters to these, except even more of a pain in the ass because we have to replace 2 characters. Okay. Insert. Can I... No. Okay. I'm trying to figure out the best way to do this. I think we do this first so we can get out of insert mode because this is going to be copy paste this before each line, then go through and delete off the characters. Okay. And now delete, 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 delete. Okay, there we go. And now you gotta look here. Okay, disk height ratio. We should go from like 0.03 to 0.1. Disk num points 150,000 to 250,000. Bulge num points 50 to 150,000. Bulge axis scale is probably fine. I think that probably is fine. These would go up, likely. Less variance because it's spinning. Voltage ratio. That's fine. All right. And I think we already changed this. E0, E3, E5, E7, E0, E3, E5, E7, S0. Yeah. All right. This is our proto spiral. Yep. All right. Looks good to me. I think that looks pretty good. All right. I think that means we have all of our cluster type or our non-spiral types. This next part is where it gets fun, but so we have our SA here. We're gonna have to do the same thing, but these are gonna probably need substantial modifications. But even so, to start, we do need all of these, so we might as well go ahead and do the insert thing. You know, insert is a mode that's not super useful most of the time until you need it. A works every time, so this is this is how fast I go when the keyboard's actually doing what it's supposed to do. It's a lot easier. Okay, so this is good, sort of. This will come down because we're gonna have to do arms and twist now, but the rest of this should be fine. Min, max. Let's get the template laid out to do the next two sections, and then I need some lunch and walk my dog, I think is what I'm about to do. There were four parameters that go into the twist. Covers the twists. We have at least 8 arm parameters, I already know. So like this. There it is. This. Okay, now we just have to do this little dance. There it is. All right, so I'm gonna get some lunch, take my dog out, and then when I come back, we'll randomize these, and then we will have um, basically our template to finish this for the rest of our archetypes, with the exception of cluster, which we'll have to do a little bit of custom stuff on. But this is great progress. We covered E0 through S0. Now we need to cover all of our galaxy, our spiral types. I think this is where we are. Okie dokie. I'll be back in a bit.